segue a little bit downtown. So I think it's going to be more like probably close to 2, but we started late. So are you okay?
Yeah, I'll survive.
Thank you.
Thank you. I flew in from New York City this morning, so it's dinner time, actually. So I'm ready. You got dinner for me here. Thank you first for this invitation to come present. And I'm familiar with many of your names and faces, and I'm even close friends with some of you out there. What I wanted to do was put some issues on the table that I have not seen commonly discussed, and that I think they ought to be front and center for these next several days. Unfortunately, I missed Professor Weinberg's talk because I tried to get here. I woke up at 4 o'clock this morning in New York City to get here, and the best I could do was halfway through. I missed your talk completely, but I got halfway.
You're forgiven.
Okay. But I learned from informants that, in fact, we have some significant overlap in our discussion of Islam from 1,000 years ago. So forgive me if I repeat some of what you might have already heard, but I'm going to bring it out anyway because there's a broader context that I want to share with you. And I'm told I have full control here. Let's see if this works. Oh, in case you're wondering, that's the Eagle Nebula. One of the few photos that you'll see that are this beautiful that are not by the Hubble telescope. This is a 1-meter telescope at Kitt Peak Observatory in Arizona, and the shape of the eagle is not discernible. It's barely discernible in this frame because the eagle is about 2 or 3 times the size of this, and the head of the eagle would be up here. So up here, and the wings off to the left and off to the right. Perhaps the most famous image of Hubble is a close-up of this zone right here, which has been variously be called the pillars of creation, God's fingers, and all sorts of other sort of religious references. People feel that way when they look at images of the cosmos, of course. I was always curious, though, that in the same universe you have things like the underbelly of a tarantula, and when magnified, no one thinks religious thoughts when they make those observations, when it's part of the same universe. So, but I'll get back to that in a few moments. So here, what I want to do is I want to highlight a few issues, and these are issues that came together for an essay I wrote that appeared in Natural History magazine, the Darwin issue. It was the opening of our Darwin exhibit that is now traveling. It's no longer there at the museum, but the Darwin issue collected together stories, articles on the relevance of evolution, not only as an important concept in biology, but an important concept in all of science. And I thought long and hard about how could I possibly contribute to this, because I don't know enough biology to be meaningful in that issue. And then I realized that there are elements of, in fact, the intelligent design movement that clearly there's a lot of teeth that people attending this workshop have put into that subject. And I asked myself, do I have anything to contribute to that? And I realized that I did. And so I want to sort of fill a niche that I think is left unfilled. So let's go through. Let me first start off with Ptolemy. I don't know if we know that he really looked like this, but Ptolemy, was one of the greatest scientists ever and most influential scientists. And his most important work is, of course, Al-Majest, which is Arabic for the greatest. And in it, he sort of codifies the geocentric universe. And this Earth-centered universe prevailed for centuries until Copernicus and Galileo turned that around. But what I want to call your attention to are notes that he penned in the margin of the manuscript of his work. Let me remind you that back then, you would look up at the night sky and the planets would move against the background stars. They would wander, because that's what the word means in Greek, is wanderer. And there were 7 of these objects, the sun and moon included. And they would just kind of move. They'd go to the left, and then they'd slow down and pause, and then they'd back up, and then they'd reverse again. And this was a mystery, complete mystery. And of course, the heavens were not Earth, and so the fact that you didn't really understand what was going up there was kind of okay and expected because that was the work of the gods. and we being mortal down here on Earth. If you can't understand it, don't lose sleep over that fact. You perhaps never will. Now, Ptolemy had sort of the best going explanation anyone had put forth with the epicycles and the like. But nonetheless, this is the boundary between what is known and unknown about how the machinery of the universe works, and he pens these words, which for me are one of the most beautiful and poetic references to the state of one's knowledge ever written. I know that I am mortal by nature and ephemeral, but when I trace at my pleasure the windings to and fro of the heavenly bodies, I no longer touch earth with my feet. I stand in the presence of Zeus himself and take my fill of ambrosia. And so therein is this emotional, he's got this sort of religious feeling at the limits of his knowledge. And this is a trend that will continue for thousands of years to follow this. At least 2,000 years to follow this. And you don't have, and this whole notion of intelligent design, this is intelligent design. This quote that I just read to you is Ptolemy invoking intelligent design. No, he's not trying to get that into the classroom. He's not, there's the politics of intelligent design in modern times. But what I think has been swept under the rug that we have to contend with as a community of people who are sort of truth seekers is the fact that some of the greatest minds that have preceded us have done just this, okay? That's Ptolemy. But we can go on. Who else do we have? Oh, Galileo, interesting case. Galileo was kind of an exception to this. We all know he was a deeply religious man, and a lot of the trouble he got into was because he was just kind of obnoxious, all right? He could have made nice with the Pope, and he did not. And of course, I'm paraphrasing. I mean, that's the Reader's Digest version of what happened over that period. But let me share with you some lines that he wrote to Christina, who was the Grand Duchess of Tuscany. Some of these quotes you've heard before, but I think they're worth taking to heart. The Bible tells you how to go to heaven and not how the heavens go. That's one of the famous quotes attributed to Galileo. Another one is, I don't feel obliged to believe that the same God who has endowed us with senses, reason, and intellect has intended us to forego their use. And so he was kind of I see him as one of the first to say, all right, if religion has if there's any point and purpose to it, it's not to serve as a science textbook. Okay, so he was kind of the first to suggest this division, not to get rid of religion. Of course, like I said, he was a religious fellow himself. But it gets interesting when we get sort of philosophically interesting when we get to this gentleman. I can back up here. Sir Isaac Newton. Now, I don't know what you know of Isaac Newton, but everything I've read of his tells me that there's no greater genius to ever walk the surface of this earth. I'm I don't know if you've ever felt that about anybody. I didn't feel that about anybody. But you just read what this man wrote, okay? Line by line by line. This guy was plugged into the machinery of the universe. I think he's unimpeachably brilliant. Unimpeachably brilliant. And let me read again what we heard from Mike Shermer earlier. In Isaac Newton's writings, by the way, in his Principia, here's the page 1, page 0 of Principia, in it, he discovers the laws of motion, F equals ma, discovers the laws of gravity. It's all there. And he did this all before he turned 26. And in this, when he talks about motion, there's no reference to God. When he talks about his two-body force that he deduced, this universal law of gravitation, there is no mention of God. It's just not anywhere there because he understood it. He was on top of it. He was there. Even though the understanding of the motions of the planets before he came along was given unto God because nobody understood it, or nobody understood well enough to really believe that they had a full predictive handle on it in the way the universal law of gravitation supplied. And so what you have is Isaac Newton abandoning reference to God until he realizes that if all you do is calculate the two-body problem, here we have like the moon and earth. Yes, he's got that calculated. Now you have the sun and the earth. You got that. But wait a minute, now the earth and the moon go around the sun, and sometimes we're close to Mars and sometimes we're not. And when it comes near Mars, there's a tug. that's stronger there than in any other part in the orbit. And then it comes over here, and then Jupiter tugs. And it's all these mini tugs. And so he's got to do this two-body problem for Earth, the Moon, Earth and the Sun, Earth, Moon, and Mars, Earth, Moon, Mars, and Jupiter, and it becomes a rapidly complex problem. And he realizes that, in fact, applying this simple sort of approach to calculating the stability of the solar system, he finds he can't stabilize the solar system. He can't account for how we have stayed this way for as long as what was possibly necessary from the beginning of the universe. And so what does he say? He's at his limits. He's at his limits. And so you read Pre-Cambrian, God is nowhere until you get to the general Sholem. And then he says the 6 primary planets. Back then there were 6 planets, okay? Now there's 8, in case you haven't been keeping track. Even if you thought there were 9, there are now 8. The 6 primary planets are revolved about the sun in circles concentric with the sun, and with motions directed towards the same parts and almost in the same plane. He's got the whole picture now, and he's trying to sort of account for that. But he can't just simply doing two-body calculations, certainly not without a computer or without a new kind of mathematics. He says, but it is not to be conceived. But is it not to be conceived that mere mechanical causes could give birth to so many regular motions? This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. This is Isaac Newton invoking intelligent design at the limits of his knowledge. And I want to put on the table the fact that you have school systems wanting to put intelligent design into the classroom, but you also have the most brilliant people who ever walked this earth doing the same thing. And so it's a deeper challenge than simply educating the public. It's deeper than, as you know, by the books written by our scientific colleagues that do take these deeply resonant and charitable positions towards their religious beliefs. Maybe the real question here, let me back up for a moment. You know, we've all seen the data. 40%, there's 90 whatever percent of the West or the American public believes in a personal God that responds to their prayers. And then you ask, well, what is that percentage for scientists? Averaged over disciplines, it's about 40%. And then you say, how about the elite scientists, members of the National Academy of Sciences? An article on those data recently in Nature, it said 85% of the National Academy reject a personal God. And then they compare it to 90% of the public. You know, that's not the story there. They missed the story. What that article should have said is, how come this number isn't 0? That's the story. Okay? So my esteemed colleague here, Professor Krauss here says all we have to do is make a scientifically literate public. Well, when you do, how can they do better than the scientists themselves in their percentages of who is religious and who isn't? That's kind of unrealistic, I think. So there's something else going on that nobody seems to be talking about. That as you become more scientific, yes, the religiosity drops off, but it asymptotes. It asymptotes not at 0. It asymptotes at some other level. So they should be the subject of everybody's investigation, not the public. I'm telling you. So it's not 85% reject, it's that 15% of the most brilliant minds the nation has accepts it. And that's something that we can't just sweep under the rug. Otherwise, we're being disingenuous to the efforts here. And I know I'm standing between you and lunch here, so let me try to go quickly. If you don't think, I think Newton is one of the most brilliant, the most brilliant ever to sort of walk the earth. And I'm not alone in feeling this. This is his statue in Trinity Church in Cambridge, and he's through the open doorway there. And so you get close to the statue. He's without his curls here. I was deeply upset by that. I thought he was like really trendy with his long hair. But apparently that was probably just a wig at all times. You look at the base of the statue, loosely translated, of the genus of all who have ever been human, there is no greater intellect than this man. And so I'm not alone in this sentiment. And this man wrote those words. So, but let's move on, because there's more to talk about here. We don't have to stop at Newton. Let's go to Christian Huygens. all right? Brilliant, brilliant scientist. I mean, he was great at chemistry, biology, physics, math, Dutch scientist. And he died the year that this work was published, one of my favorite works of science writing. And it's Cosmotheros, which is an exploration on the likelihood of there being life on the known planets, using the available knowledge of the day. So, for example, they knew that, by the way, Huygens was the first to identify Saturn's ring as a ring. If I got that right, Carolyn, is that correct? Oh, no, I thought he was the first to calculate that it would be a ring. He was then Huygens would be the first to observe it. Okay. We have Madam Saturn here in the room, in case you don't know. Okay. My colleague Carolyn Porco, who we'll be hearing from later, I've just been told. But anyhow, so Huygens, brilliant fellow, and one of the probes on the Cassini spacecraft was called Huygens, a European probe that descended to the surface of Titan. And so he's an important figure in the history of science. So what does he say in his writings? Well, you look at the year 1696, gravity was well known, laws of motion were well known, Newton was quite influential well before the turn of the century there. And so when he talks about the orbits of the planets, it's done. Talks about the moons of Jupiter, done. Talks about the new rings around Saturn, done. It's all fine. But when he talks about biology and life, something that's not well understood then or today, boom, there goes his references to God. But references to God were nowhere else in those writings. Nowhere else. He says, I suppose nobody would deny but that there's somewhat more of contrivance, somewhat more of miracle in the production and growth of plants and animals than in lifeless heaps of inanimate bodies. For the finger of God and the wisdom of divine providence is in them, much more clearly manifested than in the other. He doesn't say that about the orbits. We're done with the orbits, as Mike Shermer had noted. We're done. He's in a place where nobody really has the answer. So he invokes, this is intelligent design once again. Pure out, flat and simple. So, you know this story. I have to tell it because it's just great. All right? So Laplace, Pierre Simon de Laplace, at the end of the 18th century, wrote a 5-volume tome on celestial mechanics. A brilliant piece of work. It's there. It weighs a lot on the shelf. And what it does is it takes Newton's laws of gravity and brings them into a full expression with the hammer of calculus. Okay? He brings all the armament of mathematics to bear on the laws of physics that were put forth by Isaac Newton. Isaac Newton only touched on them. They were not fully developed. And in this work, he demonstrates, he further develops something that had been percolating in the mathematical community, but he develops, and one might even say perfects, a branch of math we would call perturbation theory, where instead of pulling your hair out saying, well, how do you calculate this pair of forces and this pair, and all the equations go to hell, in perturbation theory, it allows you to systematically and reliably calculate the effect of a small tug in the presence, a series of small tugs in the presence of singular big tugs. And that's kind of what what's going on in most of the solar system. And when you do that, and you do that properly, you can demonstrate, notwithstanding effects of chaos, which have other timescales related to them, you can demonstrate that, in fact, the solar system was stable beyond the predictions of Isaac Newton. So, he figures this out, does not invoke God, because he figured it out. And in a story that may be apocryphal, but I see more in support of it than against it, this time coincides, of course, with the era of Napoleon, Napoleon being French, and Laplace being French, no translation necessary. Napoleon, if you visited his library, it's not just sort of books of world history and battles, it's engineering books, it's physics books. This man wanted to know where his cannonballs would land, all right? He was much more than just sort of a lucky general. He was into the physics, the engineering, and the material science of war. And so he immediately summoned up the 5-volume production of Laplace, read it through, cover to cover, called in Laplace, and said, sir, I have the exact quote here. Hang on. Napoleon asked him what role God played in the construction and regulation of the heavens. This is kind of like, that's what Newton would ask. right? Laplace replies, sir, I had no need for that hypothesis. And so what concerns me now is, even if you're as brilliant as Newton, you reach a point where you start basking in the majesty of God, and then your discovery stops. It just stops. You're kind of no good anymore for advancing that frontier, waiting for somebody else to come behind you who doesn't have God on the brain and who says, that's a really cool problem, I want to solve it. They come in and solve it. But look at the time delay. This was a 100-year time delay. And the math that's in perturbation theory is like crumbs for Newton. He could have come up with that. The guy invented calculus just on a dare, practically. When someone asked him, Ike, how come planets orbit in ellipses and not some other shape? And he couldn't answer that. He goes home for 2 months, comes back, out comes integral differential calculus, because he needed that to answer that question. And so this is the kind of mind we were dealing with Newton. He could have gone there, but he didn't. He didn't. His religiosity stopped him. And so we're left with the realization, of course, that intelligent design, while real in the history of science, while real in the presence of sort of philosophical drivers, is nonetheless a philosophy of ignorance. And so, regardless of what our political agenda is, all you have to say is, science is a philosophy of discovery, intelligent design is a philosophy of ignorance. That's all. I don't need to see whether, have you discovered anything lately? If not, get out of the science classroom. But I'm not going to say, don't teach this, because it's real, it happened. So I don't want people to sweep it under the rug, because if you do, you're neglecting something fundamental that's going on in people's minds when they confront things they don't understand. And it happens to the greatest of the minds, as it happens to everyone else, many, if not most other people in the public. So let me blow through some last set of slides here. I want to call something to your attention that we all know intuitively, whether or not you've thought about it explicitly. You go around the world and you find times and places where nations have excelled in one subject or another. There's a birth of that period of where they excel, and then there's a peak, and sometimes it drops off, and sometimes they hang on. And so you can ask the culture of that. What was going on in that nation to support those discoveries? And then what happened when they ended? And so I call that sort of naming rights. If you were there first and you did it best, you name things. Particle physics in this country, in the United States, was like going gangbusters after the Second World War. And the discovery of atomic elements, look at the periodic table. There's berkelium, californium, you know, we got half the United States up there in the upper, heavier elements of the periodic table. Am I right there, Sir Weinberg? Okay, I don't wanna That's not because the world liked California or Berkeley. It's because the work was done here. It's because there was an effort to excel in just those subjects. And it shows up in other ways. Well, I'll give you just briefly. You know, part of the naming rights is that you don't have to name it. So, for example, while we didn't invent the internet, we certainly exploited it here in America. We did that sort of first and best. And so your email address does not end in .us. Everybody else is in the world, they got to say what country they came from. We don't, okay? It's simple, but it's the consequence of being there first and doing it better than anyone had done it before. Do you know that the British postage stamp is the only postage stamp in the world that does not identify the country of origin? Because they invented postage stamps. So why should they have to say what country it is? It's their invention, okay? Check them out. It's just the facts of this. The constellations of the night sky, it's the Greek and Roman, and it's lasted to this time because they did a really good job thinking that stuff up. All the mythologies of the heavens, that really stuck with us. All right, so I'm going to make a larger point, not to get gratuitous on you here, but September 11th, 2001, as we all know, this was going on in New York City. This is the view outside of my window. I live 4 blocks from ground zero. Excuse me, this is the corner of the building in which I live. I went outside to get this view. I was at the time judging whether I should go collect my daughter, who was in an elementary school 2 blocks north of the North Tower. North is to the right in this picture. So I want to get a closer view with a highly magnified zoom lens to see what, while that was happening, the plane flew into the South Tower. And so no one was thinking terrorism until the second one was hit. The first one was just sort of a bad tragedy. And so these are just 3 frames from my camcorder. This is at t = 0. This is 1 second, well, like actually a fraction of a second. The plane was moving probably 500 miles an hour. And just to understand, the black building, that black sort of monolithic building, that is 50 stories tall. This is New York City, people. So tall buildings are kind of, they're just all over the place. And that's just a hotel, a 50-story hotel. And it's, the towers are foreshortened because they're the angle at which this is shown. I put these up because a few days after this, President Bush, I don't remember where he said this, on the steps of the White House, in the Rose Garden or at the Capitol, in an attempt to distinguish we from they, the terrorists who flew these planes into the buildings and into the, that went down in Pennsylvania and in Washington, to distinguish we from they, he loosely quotes a phrase out of the Bible by saying, our God is the God who named the stars. Now, this is before I was on his Rolodex, okay? Because I could have helped him out there. The fact is, of all the stars that have names, 2/3 of them have Arabic names. So this was not, I don't think, his intent with that message. Okay? While the constellations are Greek and Roman, the names are Arabic, all right? And the list just goes on and on and on and on. And so where does this come from? How does this happen? How do you get stars named with Arabic names? How does this happen? And it happens because, of course, because, hang on, just catching up with myself here. Okay? It happens because there was this particularly fertile period that Professor Weinberg duly discussed. And around that period, that 300-year period, the intellectual center of the world was Baghdad. Baghdad. It was completely open to all visitors, all travelers, Jews, Christians, doubters, which today we might call atheists. They were all there exchanging ideas, all of them. All of them. And it was that period where you had the advances in like engineering and biology and medicine and mathematics. All right? Our numerals are called what? Arabic numerals. Now, you ever stop and think about that? You know, who as in America, do we take pause at this? Why are they called Arabic numerals? Okay, they fully exploit the discovery of the zero, create a whole field called algebra, itself an Arabic word. Algorithm is an Arabic word. All this is going on, and it's all traceable, not to some long 1,000-year tradition in Islam. It's traceable to this 300-year period. This 300-year period. And then, so they had naming rights. The most expensive, beautifully carved astrolabes come out of this period. There's a great collection of these at the Adler Planetarium in Chicago, if you ever want to check them out. So navigation, celestial navigation, all of this is traceable to this period. And so something happened. And what happened, as was previously described, I was told, and forgive me for repeating from what you might have heard, 12th century kicks in, and then you get the influence of this scholar, Al-Ghazali, all right? And so out of his work, you get the philosophy that mathematics is the work of the devil. And nothing good can come of that philosophy. That combined with other sort of codification, philosophical codifications of what Islam was and would become, the entire intellectual foundation of that enterprise collapsed, and it has not recovered since. Over that period, all these books were translated into Arabic on a scale not seen since then. And so why am I even going here? Because I'm trying to explain to you that you fast forward, the dangers here is that you fast forward to 21st century America and ask, what influences are we feeling now? Because that naming period in Islam stopped and it never recovered. Because the way of thinking about the natural world revelation replaced investigation. Okay? So I fast forward to 21st century, and what do you find? You get things like this. Okay? This is in America. All right? So now, what I find interesting is the level of passion that it requires to actually do it. You gotta like pay for this, okay? And it means a lot of people are pissed off at the Big Bang. They're pissed off at the Big Bang. At our museum in New York, the American Museum of Natural History, they come to the Big Bang exhibit, and sometimes I don't feel like having that conversation. I say, why don't you go to our hall of human biology first, and then come to us? And that's where we have sort of monkeys holding hands with people in skeleton forms, and then they never make it back to the Big Bang. They're gone forever. Okay, so however egregious the Big Bang is, monkeys and people is a worse transgression, apparently. So there's that, but there's also, here's a little bit of intelligent design here. Here's one that wants to accept the science, but then is like what's before the Big Bang. We don't quite know yet, so God was there. So of course, intelligent design is basically a God of the gaps. But my favorite way to end this, then, is to just reflect on, I want to do it just a fast tirade on stupid design, and this will be fast. Look at all the things that just want to kill us, okay? Most planet orbits are unstable, star formation is completely inefficient, most places in the universe will kill life instantly. Instantly. The people that say, oh, the forces of nature are just right for life. Excuse me. Just look at the volume of the universe where you can't live. You will die instantly. That's not what I call the Garden of Eden, all right? Galaxy orbits that we orbit once every couple 100 million years, you're bound to come close to a supernova that will wipe out your ozone layer and kill everybody on the surface who doesn't otherwise have dark skin, because your high energy rays will give you skin cancer. We're on a collision course with the Andromeda Galaxy. Gone is this beautiful spiral that we have. And of course, we're on a one-way expanding universe as we wind down to oblivion, as the temperature of the universe asymptotically approaches absolute zero. That's the universe. Then Earth, volcanoes, tsunami just killed, I think that number's higher, up 200,000 people, floods, tornadoes. None of this is any sign that there's a benevolent anything out there. And this 90% should be 99%, as was earlier noted. That's of all life that has ever lived is now extinct. Inner solar system is a shooting gallery. Comets, asteroids, duck. And look how long it took to make multicellular life. Not from the beginning of the Earth. Life happened quickly, but not multicellular life. You needed your cyanobacteria to sort of crank on the oxygen, get the oxygen budget going. Then you could have that's sort of rocket fuel for multicellular creatures. But that took 3.5 billion years. That's hardly an efficient plan with us in mind. And in human beings, this is like the most tragic of them. I don't even include here the expression of free will where people want to kill each other. I'm talking about nature killing us without the help of human beings. Aggressive childhood leukemia, hemophilia, all of this. And we so much praise about the human eye, but anyone who's seen the full breadth of the electromagnetic spectrum will recognize how blind we are. Okay? And part of that blindness means we can't see, we can't detect magnetic fields, ionizing radiation, radon. We are like sitting ducks for ionizing radiation. We have to eat constantly because we're warm-blooded. Crocodile eat a chicken a month, it's fine. Okay? So we're always looking for food. These gases at the bottom, you can't smell them, taste them, you breathe them in, you're dead. Okay? So, I'm almost done. I'm sorry, I'm taking up your time here. So, and with the birth defects, most are unknown. Look at this. Others, it's like abuse and infection and stuff that human beings had something to do with. We have no idea. Oops, I pushed a button by accident, sorry. No idea. No idea. And, and birth defects are tragic. They're tragic, particularly if they happen to the family afflicted by it. And you just look at images of these aborted fetuses because of and most of these are stillborn, others are born with a heart outside the body. And so this is all simply stupid design. And the problem is, if you look for what is intelligent, and yeah, you can find some things that are just really beautiful and really, hey, that's a clever, the ball socket of the shoulder, and a lot of things you can point to, but then you stop looking at all the things that confound that revelation. And so if I came upon a frozen waterfall and it just struck me for all its beauty, I would then turn over the rock and try to find a millipede, okay, or some kind of deadly newt, and then put that in context and realize, of course, the universe is not here for us, for any singular purpose. My favorite of all is, of course, you eat, breathe, eat, and drink through the same hole in your body, guaranteeing that some percent of us will choke to death every year, okay? Imagine if you had a separate hole for breathing and eating and talking. That would be just really cool, right? Just, you could drink, breathe, and just talk, and you would never choke, all right? And it's not a hard request. Dolphins breathe and eat through different holes in their body. And that's a mammal. So I'm not, you know, this is like Santa Claus could bring this one. And this one, of course, my favorite of all, like, what's this going on between our legs, right? As you've heard, like, you've heard it. It's like an entertainment complex in the middle of a sewage system. No engineer would design that at all, ever. It's like the wrong juxtaposition of elements. So what I want to put on the table is the fact that I don't want the religious person in the lab telling me that God is responsible for what it is they cannot discover. Because look at the hubris of that. You're in the lab and you say, I don't know how this works. And not only that, no one alive on earth knows how this works. And not only that, no one who will ever be born will know how this works. That's kind of audacious when you think about it. And then you put it down and go on to the next problem. If this problem is a cure for Alzheimer's or cancer or whatever else, I don't want them in the science classroom. And so the issue is simply about progress and discovery. And in my recent forays into Washington, well, I've been closer to a community of Republicans than I have ever been in my life, because I grew up in New York City. And in New York City, I think that person is Republican back there. You see? No, not that one, the one behind that person. Yeah, that's a Republican. There's another one. That's in New York. So you grow up this way, and I get sort of baptized into a Republican administration. I had 2 consecutive appointments in the Bush administration, one on aerospace, on the aerospace industry, and one on space exploration, NASA's future, basically. And I realized something, spending that much time in the community of powerful Republicans, that Republicans, above all else, do not want to die poor. So, there's a limit to how far this will go. And I bet most people in this room, even those assembled at this table, were highly concerned about the Dover trial, wondering how that would turn. And I looked at that and I said, I'm not worried, because it's a Republican judge. And in the end, if you put people who are not making discoveries in the science classroom, that is the end of the foundation of your future economy. And so I had a little more confidence than others did because of this sensitivity to the money aspect of it. But we all know tomorrow's economies will be founded on innovations in science and technology, and of course that gets cut short if we lose our civilization, as what happened in Islam in 1100. And the last thought I'll leave you with, which concerns me greatly, if you do the math, okay? You know, you look at all the Nobel Prize winners there ever were, some even in this room, and ask how many were Muslim. And it's like 1, maybe 2, okay? I think a second one was in economics. And the one we referred to was described earlier, the co-winner of the Nobel Prize with Professor Weinberg, Abdul Salam. And he's not Middle Eastern Muslim, he's Pakistani Muslim. Okay? Now, how many Nobel Prizes are won by Jews? It's like a fourth of the Nobel Prizes. Okay? Some high fraction of the total. And then you look, how many Muslims are there in the world? It's like 1 billion Muslims. How many Jews? 15 million tops. Okay? So you just ratio these numbers. Had Islam not collapsed in its intellectual standing in the year 1100, and you just do the ratios, they would have every single Nobel Prize today. So the fact that it's not only just a few, it's near zero, is deeply worrying. I'm concerned about what brilliance may have expressed itself and did not in that community over the past 1,000 years. And so what I want to put on the table is why, so that's the end of my talk, but I want to put on the table not why 85% of the National Academy rejects God. I want to know why 15% don't. And that's really what we got to address here. Otherwise, the public is secondary to this. Thank you for your attention here.